Hello again, everyone. Now, in the last section, we were talking a little bit about covalent bonding and reminding ourselves of roughly how that works. We looked at some Lewis dot structures to show electrons in the outer shell. I'm going to continue with this train of thought, but in particular, we're going to start to talk about what covalent bonds look like in organic chemicals specifically. So, for organic chemicals, there are two main bonds. There are other bonds that exist that make chemicals special, but the bread and butter, the main bits that you're going to see all the time are carbon-carbon bonds and carbon-hydrogen bonds. Now, remembering that these bonds here are covalent bonds, they represent two electrons that are being shared between the two atoms. And when they're shared, they end up binding together and forming quite a strong bond, as we talked about before as well. Now, to understand how these bonds work, we also need to understand what the outer structure of carbon and hydrogen look like. Now, I'm going to start with carbon. So carbon, if we look at our periodic table, sits in column 14. I was saying before, it has 4 electrons on the outer shell, which is directly in between the 8 and 0 kind of deal. When we're talking about ionic compounds, when they give or receive electrons, these guys don't usually form any kind of ionic compound because it takes a lot to give or receive 4 electrons. So you won't usually see them in ionic compounds. Usually you'll see them in covalent ones, which is what we're looking at right now. So carbon has 4 electrons on its outer shell, and I'm going to draw them up now. I'm going to draw one on every side. Essentially, what this means is carbon can form 4 covalent bonds. It has the ability to participate in a covalent bond by giving one of its electrons to some other atom that's near it to form a covalent bond and share its electrons. Hydrogen, on the other hand, and I'll pull up the periodic table once more, hydrogen sits in column 1, which means that it only has 1 electron available. Oh, excuse me. Has 1 electron available. We'll give it a sec to do a little bit of... There we go. 1 electron. Let's draw that in. That's where I'm at. If there's only 1 electron, it can form 1 covalent bond. It can form 1 covalent bond because there's only 1 electron for it to give to a covalent bond, 1 electron for it to share. So, as an example, what we might have here is, I'm going to start making a molecule with our carbons and our hydrogens. Our carbon might come across another carbon. Now, both of these, I'm going to draw my electrons with slightly different symbols so we can tell which electron's coming from which atom. So we have our 2 carbons here, the carbon on the left with a dot, and our carbon on the right, I'm drawing with an open circle electron. They can form a covalent bond and bond together. However, both of these carbons still have 3 other electrons, which means that it can still form 3 more bonds each, or both carbons can form 3 bonds each. Now, at the moment, remembering that we're sharing electrons to get a full outer shell, at the moment this carbon here, we're going to call it carbon number 1. Carbon number 1 has 1, 2, 3, 4 electrons to start off with, and is sharing a 5th. At the moment, it does not have 8 electrons on its outer shell. It's not particularly happy. At the moment, we have not made an organic chemical. This would not exist in real life because not everything's happy yet. Our carbon over here, carbon number 2, has 1, 2, 3, 4 electrons that it started with, plus it's sharing one from carbon number 1 as well. So it's got that fifth electron there. Again, it's not happy either. What we could do is bring in a third carbon, and I'm going to start forming a chain here. This will be our third carbon. I am going to be marking this with crosses. It has 4 electrons on its outer shell as well. It might form a bond with our second carbon, carbon number 2. Now at this point, carbon number 1 still has 1, 2, 3, 4, 5 electrons on its in its outer shell. Carbon number 3 has 1, 2, 3, 4 to start with, and a fifth from carbon number 2, so 5 in the outer shell. Carbon number 2, because it's formed another bond, has 1, 2, 3, 4 at the beginning, still has its fifth from the third carbon, but it also now has a 6th electron that's being shared with carbon number 3. Hoping that you're starting to see a pattern here that if each of the carbons form 4 covalent bonds, it will mean that it will have its 4 electrons that it started with, and it will also have 4 electrons that it has shared with through its bonds to make a total of 8. Now, what usually happens is once you've made a carbon chain, unless there's any other special parts of the chemical, the rest of it gets filled with hydrogen. So that's what I'm going to do. At every single spot where there's an open electron, I'm going to put in a hydrogen. And they're all going to be marked with triangles for electrons. So each hydrogen has 1 electron that it has available to bond with, and they're all going to be triangles. They all form covalent bonds all the way around. Now this is starting to get quite messy because usually we don't draw it in this kind of detail. Hopefully, just because we're looking at it for the first time, the coding is going to help maybe a little bit. Maybe it won't, and the second drawing that I'm about to draw might make more sense. But here, this carbon in the center, carbon number 1, 1, 2, 3, 4 electrons that it started off with, and then an extra 4 from all the bonds that it's formed. It now has an outer shell of 8. This carbon number 2 has 4 electrons that it started with in its outer shell. But then all of these guys, 1, 2, 3, and 4, from all of the bonds that were formed again from its covalent bond. So these 4 covalent bonds have introduced these 4 extra electrons, and it has an outer shell of 8 too. Carbon number 3 starts with 4 electrons. It's the same kind of story and has formed 4 bonds all the way around, meaning that there are 4 extra electrons and it has an outer shell of 8 as well. All of these carbons are now happy. They all have an outer shell of 8. All of the hydrogens are happy because they all started with 1 electron, one of those triangles, but has bonded with one of the carbons to then have an outer shell of 2, remembering that 2 is also a happy number. But that's only pretty much for the hydrogens when we're talking about our organic chemistry. So 8 electrons for all the carbons, 2 electrons for all the hydrogens, everybody's happy. Now we usually don't, as I said, draw to this extent. We don't usually use those Lewis dot structures when we're drawing up our organic chemicals really quickly. What we assume is that we can just use these dashes like I've drawn up here that represent a covalent bond with 2 electrons in it. And so what that might look like, just so it's a little bit more clear, is a chain of 3 carbons that are all bonded together, that are also bonded to all of the hydrogens on the outside. In every case, we want our carbon to form 4 covalent bonds because it starts with 4 electrons and then gets its extra 4 to make 8 through all 4 of those bonds. The hydrogen can only form 1 covalent bond, and so when it does that, it starts with its 1 electron and gets its second one and gets its full outer shell. So these are kind of pseudo rules that we have when we're constructing our organic chemicals. Essentially, we have our 4 bonds for our carbon and our 1 bond for our hydrogen. When we form our 4 covalent bonds, we have an outer shell of 8. So I've written there 4 bonds make 8 electrons in the outer shell. And for hydrogen, the 1 bond will make 2 electrons in the outer shell. Both of these are stable configurations, everybody's happy. And we've shown that maybe a little bit more clearer here. By looking at this chemical, I can see that the carbon has made 1, 2, 3, 4 bonds all the way around. This carbon here has made 1, 2, 3, and 4. The carbon on the right, 1, 2, 3, and 4. Those 4 bonds make 8 electrons in the outer shell. Everybody's happy. Then if I look at the hydrogens, I see that this hydrogen's made 1 bond, and this has made 1, this has made 1, this has made 1, this has made 1, all the way around. They've all made 1. And again, it's happy because it has 2 electrons in its outer shell because it's made 1 single bond. Now, I'm going to talk about this a little bit more in depth, but this is a particular chemical. It is an organic chemical. There's a naming system that we're going to start running through soon. Just for the sake of it, I'm going to write it down at the moment. So this one is called propane. Now, there is a fairly in-depth system that leads to us naming it as such, and I will talk about that in further sections.